page 5 of your lab manual. Step number 1 says to have 3 items for determining their mass. I have here a battery, a Sharpie, and a pair of scissors.
I'm going to pause at this point just to let you know that you should have your data sheet in front of you so you can record all this. So if you didn't do that already, you want to get it out now. So you can pause the video if you need to, but have that ready. I'm going to start it back up again now.
And we're going to put them on the balance. The balance has been zeroed, and we're going to record their masses. The scissors.
One thing here, make sure you record all the numbers that you see on the scale, including zeros. You must have 3 digits to the right of the decimal point because that's how accurate the balance is.
It's your job to record the data in your lab manual, the Sharpie. And the AA battery. Record the masses of those 3 in grams and then convert them each to milligrams and kilograms. Continuing with lab number 1, basic laboratory techniques. We are on part 2, measurement using a meter stick, and that data will be collected on page 6 of your lab manual. We are going to do one object, not the textbook and the calculator. We're just going to do one object. First, we need to...
Let me pause right here. When you are finishing up the first part where they've measured the masses and you're getting all your values in grams, use conversion factors to convert from grams to kilograms and grams to milligrams. If your answer comes out to be greater than 1,000, put your value in scientific notation. If your value comes out to be less than 1/100th, put that value in scientific notation as well. Make sure that the number of significant figures that were in the masses is the same as the number of significant figures that you calculate for milligrams and kilograms. You cannot change the number of significant figures when you change a unit.
Look at our measuring device and determine the smallest increment of measure on each side. Here's the centimeter side.
I want to point out that the centimeters are the numbers, and the lines between them, there are 10 lines between them, those lines are viewed as tenths of a centimeter. I know you might say, well, aren't they millimeters? Well, that's true, but we use this ruler to just measure to the tenths place in centimeters. It's extremely hard to guess what it might be between tenths, so to read hundredths is almost impossible. So keep all your values to the tenths place in centimeters.
There is the inch side.
Now here, a lot of people think quickly that, oh, it must be broken up into 10 places as well. But if you count all the lines that you see between, for instance, the 1 to 2 inch area, you would count 16 lines. So the smallest increment on the inch side is a 1/16th of an inch. And then the larger lines you see there are 1/8 of an inch. And then the larger lines even than that are 1/4 of an inch. And the largest line in the middle is a 1/2 inch. So you're just getting fractions here. So that's another reason why our measuring scale in this country, in terms of inches anyway, broken down into fractions is a little bit more difficult.
Now we want to record the length of our object. We're using this model kit as our textbook. Here is the length of our object on the centimeter side. Record this using the proper number of significant figures.
Make sure you're just recording the centimeter side. I realize it's a little fuzzy, so you're going to have to estimate where you think the little lines are. You can see that it's longer than 23, but 23 point, well, you have to decide what that is.
There's the width on the centimeter. And here is the height in centimeters. And after you record those centimeters, measurements, and proper number of significant figures, you're going to calculate the volume of this object.
Remember that you're not doing a textbook here, you're doing that model kit. So on your data sheet, you could always just cross out the word textbook and write in model kit.
And the correct number of significant figures. Now we're going to repeat the length and height in the length and width in the inches side. Here is the length in inches. And the width in inches. Record these with a proper number of significant figures and calculate the area in the correct number of significant figures.
Formulas that you need to calculate volume and area are on the procedure sheet, and it's page, page 2 at the top.
All right, we're continuing with Lab 1 on laboratory techniques, and this is part 3 on temperature measurements. We have, and you're going to be recording your data on page 6, bottom of page 6 and the top of page 7 in your lab manual. We have here a sample of room temperature water, and we want to record the temperature of the room temperature water. And we have some ice water here. And after the reading stabilizes, we want to read the temperature of our ice water. And then last, we have some boiling water here. On our hot plate, we didn't use the Bunsen burner, just using a hot plate to boil the water. And we want to record the temperature of our boiling water once the reading stabilizes. And that's the data that goes on the bottom of page 6 of your lab manual. Now you also want to record that as when you go over to page 7 of your lab manual at the top, you want to record that as the 0 time temperature of the boiling water. I wrote it down as 101.2 degrees Celsius. Now we're going to turn off the hot plate, and we're going to start a 2-minute timer. And we're going to be looking to record the temperature of the water after 2 minutes of cooling. I'm keeping track of the time here. So far that is 1 minute of cooling. Cooling for 1 minute and 30 seconds, with 30 seconds remaining. You'll hear a beep, and that is when 2 minutes of cooling are up, and you should record that temperature in the data table at the top of page 7. I'm recording it. Now, the manual says to follow this for 20 minutes, but in order to make this video reasonable length, we have followed the data, the cooling for 20 minutes, and here is the data for 20 minutes of cooling. And you can record this in your lab manual, and that should be the data you need to make your cooling curve.
Now, in order to make a cooling curve, they're referring to making a graph. Now, you can use Excel to make a graph. It's pretty difficult to do it otherwise.
All right, we are continuing with our first laboratory techniques. This is part 4, volume measurements. You're going to be recording your data on page 7 of your lab manual. We have 3 pieces of glassware here on the lab bench for measuring volume. This is a beaker right here. It is marked in milliliters. This is an Erlenmeyer flask here, also marked in milliliters, but different increments. And this is a 100 ml graduated cylinder in milliliters as well. We're going to use these 3 pieces of glassware to measure the volume of this water here, which we've colored blue just to make it more visible. So we're going to pour this water into our beaker. And on page 7 in your lab manual, record the volume of this water, reading this beaker.
I want to point out, when you look at this beaker, you look at the graduations, you see we have 80, where the liquid seems to be very close to. And then the next line, we don't have any number, and then the next line below that, it says 60. So the middle line must be 70. And so what could you say if you were going to read this volume? Would you say 80? Would you say 70 something? I mean, it looks like the level might be a little bit below the 80 line. What could you say then? If it isn't 80, would you say 79? Would you say 79.2? Can you even measure it to the tenths place? So I would say you really shouldn't. In fact, the most you can do is guess at if it's 79 or 78. So that's probably the best way to do this. But I think the video is a little bit off on that. So give your best shot at it and record that as the volume of the liquid in the beaker.
To the correct number of significant figures that the increments will allow. Now we're going to move this same water over to the Erlenmeyer flask. It's the same water, but the markings on the flask might be.
Now let's take a look at these graduations. You have 50, 75, 100, 125. So between, for instance, the 50 and the 75, you have 25 milliliters. So it looks like it's harder to read it here than it was in the previous one. So we can tell 50 from maybe 75, but we can't tell where would 55 be, or where would 62 be. It's very difficult. So the most you could do here would be to maybe have 2 significant figures. So do the best you can reading that. Now remember, this is the same liquid.
Read the volume differently to the different number of significant figures. Lastly, the water is going into our graduated cylinder. And record the volume of the water to the correct number of significant figures using the graduated cylinder.
Now with the graduated cylinder, you can see that here we have 10 lines between the 80 and the 70 milliliter marks. Because we can tell for certainty whether it's 71 or 72, we're supposed to go one place beyond that. So when you go to read this volume, you want to have a number in the tenths place. Now you could not go to the hundredths place because you're guessing at the tenths place. So you can only have one guess, and you're supposed to have one guess.
The volume measurements might be different.